Today, we shall be discussing about the economy and the environment. Our learning outcomes from this course structure are: number 1, interlinkages between the economy and the environment. Here, we shall be dealing with how the environment impacts the economy. Number 2, determination of the optimal level of externality. Given the fact that we are treating the environment as an externality, we shall find out how we can determine this optimal level of externality. And number 3, the different instruments for government intervention to arrive at this optimal level of externality. Once we know that the environment is an externality, our next step is to find out how the different instruments can be used so that we can ultimately arrive at this optimal level of externality. Let us start with the course structure. Suppose an economy is divided in two sectors, the production sector and the consumption sector. The production sector may comprise of firms which produce goods and services, and the consumption sector may comprise of individuals or the consumers who are consuming the goods and services produced by the firms. Now, the production sector uses the raw materials from the environment to produce these goods and services. It may use material resources like iron ore or energy resources like oil from the environment. So basically here, the environment is acting as a supplier of raw materials to the economy. Now, while we are talking about resources, resources can be identified as of two categories: renewable resource and non-renewable resource. Renewable resource will be identified as those resources which can regenerate themselves. For example, trees. For example, fishery. Both these type of resources, let us take the example of, say, trees. Even if we cut down trees, trees have the ability to regenerate themselves. Same with fish also. Thus, they are called renewable resources because they can regenerate themselves. On the other hand, we have the non-renewable resources or the exhaustible resources because they cannot regenerate themselves. Or even if they regenerate themselves, they take a very, very long time to do that. Example, oil, minerals, etc. Now, the relationship between renewable resource and the non-renewable resource can be explained with this diagram. In this diagram, we have two types of resources, renewable and exhaustible. Now, one thing we have to keep in mind that even for renewable resource, if the rate of extraction or the rate of harvest is much greater than the rate of growth, then ultimately the stock of the renewable resource will also be depleted because they will not have the time to regenerate themselves. This simple diagram basically explains this interrelationship between the two. When the rate of harvest is less than the rate of growth, the renewable resource have the capacity to regenerate themselves, but if the rate of harvest is greater than the rate of growth, then ultimately even the renewable resource will one day turn into non-renewable resource. So from here, we understand that there are two basic differences between renewable and non-renewable resources. Renewable resources have the capacity to regenerate themselves, for example, trees, and non-renewable resources do not have the capacity to regenerate themselves. Example of renewable resource we can take as fishery, the fish population, the trees, forestry, such that even if we cut down trees, if we plant them, then we can again have the forest back. Now, while we're talking about production, we have to remember that while the production sector produces, it also generates wastes. Not only the production sector, the consumption sector also creates waste. For example, say the production sector produces a bottle of Coca-Cola. Now the consumption sector uses them. Now when the consumers throw away or litter these Coca-Cola cans, then wastes are also created. Even the natural ecosystem also creates waste. For example, trees dispose of their leaves. So wastes are generated at every stage. Now, a certain part of this waste are recycled back into the environment. For example, the lead of some car batteries are used back. Again, many materials from the consumption process are also recycled back into the consumption sector. However, a majority part of the resources of the output that we use daily are not recycled back. So where do they go? They go back to the environment. So here the environment acts as a kind of waste sink, or it acts as an assimilator of wastes. That is actually the second function of the environment. Now, I'll use a simple diagram to show how this creation of waste and disposing them can actually harm the environment. As we were saying that the environment has a natural capacity to absorb these wastes. However, the fact is that the environment also has a threshold limit up to which it can assimilate these wastes. If we cross this assimilative tendency, if we cross this assimilative limit, then we will ultimately damage the functions of the environment and we will end up damaging ourselves. This diagram actually shows the threshold limit beyond which the damage starts to increase. It can increase exponentially. Lastly, we have another function of the environment which we often kind of tend to forget to. The environment also provides us direct utility in the form of aesthetic values, spiritual comfort, etc. For example, people flock to the Himalayas even today for their majestic beauty. People go to the Himalayas, monks stay in the Himalayas, the foothills of the Himalayas for meditation purposes. Even the common people go to the Himalayas to seek peace and solace from their mountain lives. So, we have ultimately three major functions of the environment. I'll show a diagram here. In this diagram, we have three circles, E1, E2, E3. E1 shows the function of the environment where it is supplying the resources. E2 shows the function of the environment where it acts as a waste sink. And E3 is the function of the environment where it provides aesthetic and spiritual values. At the top, we have the two sectors, the production and the consumption sector. On one hand, the values of R, they indicate that the waste that are generated from the production and the consumption sector are recycled back into this sector. However, a major part of these wastes are not recycled back. Instead, they are absorbed by the environment. Note, students, that the three circles actually are overlapping with each other. Now, what does that mean? This means that the three circles are interlinked with each other. For example, if we use the mountains for extracting too much of mineral resources, then we shall be reducing its ability to supply us with aesthetic and spiritual values. So, finally, what we have learned so far? We have learned that the economy and the environment are related to each other. My question to you would be, describe how they are interrelated, or rather, what are the functions of the environment? The functions of the environment can be described as, number one, as supplier of raw materials. Number two, as acting as a waste basin. And number three, providing us direct utility through its spiritual comfort and aesthetic values. Next, we move on to our section where we will show how the environment includes, or how the environment gets incorporated in the utility function and changes our normal utility values. For example, let us take an utility function where we have normal goods and services which are shown by x, x1, x2, xn, and qi's, q1, q2, qn, where xi's are the normal goods and services and qi's are the environmental assets. UA denotes the utility of individuals. Now suppose, let us take an example that there is an increase in car services on the road. There has been an increase in demand for cars, and the production sector has produced more cars following that increase in demand. So we have more cars applying on the roads. What does that mean? The increase in car services will lead to an increase in utility from the consumers. They will be able to reach their destinations more easily. However, with the increase in car services, what happens? The cars emit smoke, so air quality is compromised. So ultimately, pollution is increased. That means the utility of the consumer also diminishes because of increased usage of the cars. So ultimately, what happens depends on the relative strength of this positive and the negative effects. So the thing to remember is that, students, when we incorporate the environment into our utility function, the whole scenario changes. This was a limitation of normal microeconomics which we had studied earlier when we did not incorporate the environmental assets. Now, we have to find out this optimal level of externality. As we mentioned, say pollution, we can take pollution as an example of negative externality. So now we have to find out how to determine this optimal level of externality. Let us start with an example. Say there is a stream where there is a factory on the upstream side of the stream, and this factory produces industrial wastes which are dumped into the stream directly. Now, since the industrial wastes are dumped into the river, into the stream, it creates pollution for the stream, whereby the fish population gets to dwindle slowly. This creates a financial loss for anglers downstream. So this is an example of negative externality. So we have to find out that optimal level of economic activity where the externality the negative impact of externality can be minimized. Often students ask that, can pollution be minimized? Now, given the fact that pollution is an effect of economic activity, it is not feasible to say pollution can be eliminated totally, because zero pollution would also mean zero level of economic activity, which is not feasible. Let us look at this diagram. In this diagram, we have two curves. One is the MNPV curve, which is the marginal net private benefit curve, and it is downward sloping. On the other hand, we have an upward rising MEC curve, which is the marginal external cost curve. On the horizontal axis, we are measuring the level of economic activity, and the vertical axis measures the costs and benefits associated with such economic activity. Now, how do we arrive at this marginal net private benefit curve? When a polluter takes or indulges in any activity, it creates benefits for it in the form of revenue, as well as it incurs some cost for him. The difference between this revenue and the cost gives rise to the private net benefit. The marginal net private benefit curve shows the extra unit of private net benefit which arises because of one extra unit of economic activity. Similarly, the marginal external cost curve shows the value of the extra damage which is incurred from undertaking one extra unit of economic activity or by producing one extra unit of output. What is the optimal level of externality? The optimal level of externality is reached where the MNPB curve intersects the MEC curve. And as we can see from the diagram, this occurs for output level Q star. So, Q star is that level of economic activity which will give rise to the optimal level of externality, or say the optimal level of pollution. So, students, what we have learned from this section? We have learnt about how to find out the optimal level of externality. You can ask this question, that what is the MNPB curve, the marginal net private benefit curve, and why it is downward sloping, or what is the MEC curve, the marginal external cost curve, and why is it upward rising from this section. Now, we finally move on to our last section. The last section talks about the different instruments to control pollution or a negative externality. So, in the previous section, what we have learned? We have learned that we can treat pollution as a negative externality. Now, when we know that pollution is a negative externality, our aim would be to find out how to arrive at the optimal level of pollution. We cannot stop pollution totally, because that means our economic activity also has to be turned down to zero level. So, therefore, what we are looking at is to find out the optimal level of pollution so that the damage can be minimized. The environmental damage is minimized. Now, the government can issue different types of instruments such as taxes, subsidies, etc., where it can control pollution or it can control the externality. These interventions can be of different types: taxes, subsidies, standard setting, or permits. I'll come to taxes and subsidies later on, but before that, I'll explain what standard setting and permit system means. In standard setting, the regulatory authority, preferably the government, it sets up a limit, or it sets up a standard where every pollution bodies have to abide by. That is, there is a limit to these pollution emissions. Permit system also operates in the same mode, except that permits are tradable, they can be bought and sold in the market. The standard setting method is particularly very popular in the Western world. Now we come to taxes and subsidies. I have a diagram in front of me. As I said, that once we know that pollution is a negative externality, our aim would be to find out the optimal level of pollution. So, what does the government do? Now, the government imposes a tax on each level of activity. Now, when the government imposes a tax on each level of economic activity, the MNPV curve, which we have explained in the previous section, the marginal net private benefit curve, it shifts downward to MNPB minus T, the curve which is shown in dotted lines. So, how do we come to the optimal level of taxation? As any polluter would want to maximize his private benefits, so here also the polluter would come to that point where he can maximize from his economic activity, and this occurs at the point Q star. So, the optimal level of taxation is equal to the amount of the marginal external cost. We have to remember that when we impose tax, the price of the polluting product must equal the marginal social cost. This follows from the fact that the MNPB must be equal to the MEC. So, the optimal tax is equivalent to the marginal external cost at the optimal level of pollution. However, there are certain problems with the setting up of taxes. Number one, if we want to set up the optimal tax, we have to know about this marginal external cost curve and also the marginal net private benefit curve. Unless and until we have a fair idea about these costs and benefits, we cannot draw the MNPB curve or the MSC curve. And unless and until we are able to know the intersection of this MNPB or the MSC curve, we will not be able to arrive at the optimal level of taxation. Next, it is also possible that farmers or other individuals in the society are often outside the normal cash economy which a nation has. So, in that case, it will be very difficult to exert taxation on them. They will not be willing to pay any taxes to the government. So, taxes as a method, though it is a low-cost method compared to standard setting, is not that popular. So, this section is almost covered. Let us quickly revise what we have learned so far from this course. We started off with the interaction between the environment and the economy. We learned about the different functions of the environment, E1, E2, E3, which we have seen in a diagram, where E1 is that function of the environment where it provides materials and resources to the economy. Number 2, it acts as the source of waste sink for the economy, where those wastes which are not recycled back are absorbed by the environment. However, there is a limit up to which the environment can accept these wastes. This is known as the assimilative capacity of the environment. And lastly, the function of the environment, where it provides us with spiritual, aesthetic and other types of comfort. Next, we have seen how we can incorporate the environment in an usual utility function and shown that environment can have, or any economic activity can have, both positive or negative effects when we incorporate the environment. The ultimate result depends on the strength, the relative strength of these positive and negative effects. From here, we have moved on to how to find out about this optimal level of externality that we are speaking of. We have drawn a MNPB curve, that is the marginal net private benefit curve, and we have drawn a MAC curve, the marginal external cost curve. The MNPB curve, or the marginal net private benefit curve, explains how private net benefit is increased if the polluter increases his economic activity or output by 1 unit. Similarly, the MAC curve shows how damage will be increased if the polluter increases his economic activity or output by 1 unit. The optimal level of externality is arrived when the MNPB curve intersects the MAC curve. That gives us the optimal level of externality. Third, we have learnt about the different methods of government intervention, which helps us to derive at this optimal level of externality. These intervention can be of different kinds: taxes, subsidies, standard setting, and the permit system. Now, in case of standard setting, which is actually the most common form of regulatory instrument used throughout the world, standards or limits are set by the regulatory authority, where every pollutory bodies have to abide by. The permit system also follows the same method, except that permits can actually be traded in the market. Yes, they are tradable, they can be bought and sold. Taxes, among these, is probably one of the least cost methods of government intervention. However, taxes are not very popular because to find out the optimal level of taxation, we need to know about the MNPB curve and the MAC curve. Unless and until we have an idea about the cost and benefits from taxation, it is not possible to derive at the optimal level of taxation. I hope, students, this course helps you to understand the basic nuances between the economy and the environment, and how different forms of government intervention can help us to control environment as an externality. The main objective that we had in this structure was to find out that level of economic activity where goods, both economic and social, can exist side by side without the environmental damage taking place. I hope I have been able to answer all your questions. There are several graphs in this course which will help you to analyze the relation between the economy and the environment better. Thank you, everyone.